Section 4.6 is numerical integration. We're going to look at some more refined methods of finding the area under a curve numerically, because we still will have integrals that cannot be integrated using the methods we've talked about in this chapter. So numerical integration, these are a little bit more accurate than finding the area under a curve using rectangles. So trapezoidal rule is one of the rules we'll talk about, and Simpson's rule. The trapezoidal rule is the same basic idea as using the rectangle to find the area under, using rectangles to find area under a curve. So if we had this curve here and we used trapezoids, you can see that the trapezoids would have, since it's angled on that one side, would actually be a better approximation than those rectangles, because the rectangles would have pieces that are way above or way below the actual area of the under the curve. So if you think about a trapezoid, if we have this right trapezoid, this is base 1 and this is base 2, and this would be the height, and the area of a trapezoid would be 1/2 times the height times the sum of the two bases. So if you think about this trapezoid here laying on its side, this is base 1 and this is base 2, and this is the height. So the height is the distance on the x-axis, like the width of the rectangle in the past. And then this angled side is the other side of the trapezoid. So all of our trapezoids are on their side. If this is A and this is B, the width of each trapezoid would be B minus A over N. So that's this part, B minus A over N here. And the 1/2 is here. Here's the 2 in the denominator. Now all this part added up here is actually all the bases added up together. We're going to add base 1 plus base 2. And since 1/2 times the height is times every single trapezoid, we just pulled that out in the front here. So this represents the 1/2 times the height. And base 1 on this left side here is represented by f of x sub 0. So this first value is x sub 0, and when you plug it into the function, the base 1 is f of x sub 0. Base 2, if this is x sub 1, then the height here is f of x sub 1. Why is there a 2 in front of it? Because we'll also use it for the left side of this trapezoid number 2. So f of x sub 1 is used twice. It's used as the right base for the first trapezoid and as the left base for the second trapezoid. Same thing for f of x sub 3. It's used twice, so it has a 2. And so on, all the way to the end, except that right trapezoid, this very last one, this right side is only used once, just like the left side of the first trapezoid is only used once. So that's the trapezoidal rule. Your calculator program, I gave that program to you. It's called TRAP, I believe. Yep, TRAP. Has this programmed in. So if you're trying to use the trapezoidal rule to approximate the integral from 0 to pi of sine x dx, let's say we're using 4 and then 8. So let's use our program on our calculator. The first thing you need to do is go to y equals and type in sine of x. Then go to program and choose the TRAP program. And it asks you for the number of subintervals. So let's type in 4 first of all. And then A is 0 and B is pi. And then hit enter, and it gives you the area of approximately 0.086. So check it and make sure that yours does that. Then you can do the same thing for 8, and hopefully you'll realize that the more trapezoids you use, the more accurate your approximation will be. They're actually both 0.086, so they're both pretty accurate to 3 decimal places. To do this by hand takes a little bit more work. Let's talk about a typical non-calculator type question. So on the AP test, they would actually use a trapezoidal rule without a calculator. They know you have the program. So what's the point of using the program, right? So they might have a program question as part of a bigger question, but more likely they would have a trapezoidal rule question that requires, that's on the non-calculator portion, and it might look something like this. The function f is continuous on the closed interval from 1 to 10 and has values that are given in the table below. So they don't give you a function, they just give you pairs of x and y values. Using the subintervals from 1 to 4, 4 to 6, and 6 to 10. So we're only using 3 subintervals and they're not even equal width. What is the trapezoidal approximation? So they expect you to know that you need to make a trapezoid out of each of these regions from 1 to 4. So thinking about our trapezoid from 1 to 4, the x value here is 10 and the x value for 4 is 10. So that's not even a trapezoid there. So what's the area of that, quote, trapezoid? It would be, the width is 3, so the area would be 30. It's just a rectangle. Even though this goes up at 20, so if we actually graphed the y values, it would have a peak here, but we're just approximating. So the area of that first region from 1 to 4 would be 30. And then from 4 to 6, 6 goes up to 40. So then we need the area of that trapezoid. The width is 2, and the area of a trapezoid is 1/2 times the height, and that would be this 2 here. So think about the trapezoid on its side, times the sum of the two bases. So 50 times 1/2 times 2 would just be 50. And then the last trapezoid goes from 6 to 10. And again, the height at 10 is down to 10. So that trapezoid looks like that. This side's 40, this side's 10. The width is 4, or the height. So that area would be 1/2 times 4 times 10 plus 40. So that is 2. 1/2 times 4 is 2 times 50, so that's 100. So that trapezoidal approximation would be 180 because you add the 3 pieces together. Simpson's rule is another rule for approximating. For Simpson's rule, you must have an even number of intervals. And I'm not going to explain where this comes from. It's not really trapezoids, it's different subintervals or different shapes. B minus a over 3n is the coefficient out in front, and you start with f of x sub 0 again, but the coefficients alternate from 4 to 2 to 4 to 2 to 4 to 2, and they end in 4. So they start and end on 4, and then the last one is 1, just like the first one is 1 for the coefficients. So approximating the integral from sine x from 0 to pi of using Simpson's rule with 4 and then 8 subintervals. Let's do this one by hand. So b minus a is pi minus 0 over n. Let's do 4. And then times 3. So that's that coefficient in there. So we're going to have pi over 12 times the integral of f of x sub 0. We have to figure out what our x sub 0s are. What our x values are. X sub 0 is 0. X sub 1, x sub 2, x sub 3. So our width of each interval is b minus a over n, so pi over 4. So x sub 1 is pi over 4. X sub 2 is 2 pi over 4, which is pi over 2. X sub 3 is 3 pi over 4. And finally, x sub 4 is pi. So f of x sub 0 means you plug 0 into the function, so I need sine of 0, plus 4 times sine of the next value, so sine of pi over 4, plus 2 times sine of the next value, which is pi over 2. Alternating coefficients, 4 times sine of the next value, which is 3 pi over 4. And now we're at the last one, so we just do sine, no coefficient here, of pi. Using our unit circle, this would be a question they could put on the non-calculator portion of the test. Sine of 0 is 0, plus 4 times sine of pi over 4, that's square root of 2 over 2, plus 2 times sine of pi over 2, that's 1, plus 4 times sine of 3 pi over 4, that's positive square root of 2 over 2 again. Plus sign of pi is 0. This cancels, so we have 2 root 2 plus 2 root 2. All of that is still times pi over 12. So we have pi over 12 times 4 root 2 plus 2. And you can simplify that, or let's use our calculator to get the decimal approximation, just so we can compare it when we do the calculator. But on the AP test, if this were a non-calculator portion, you could just leave your answer like that. So it's about 2. It's 2.00456. Now let's use the calculator. So again, you should still have y equals sine x in your y equals. Go to Program, go down to Simp. That's Simpson's rule. And it asks for the number of subintervals. We did 4. 0 for A, pi for B. Oh, it gave me 0.086, which it should. I must have made a mistake in the other part. Pause for a moment here. Oh, I found out what I did. I had my calculator in the wrong mode. So if you put your calculator in radians, you do get 2.00456. So you were probably confused back here about the 0.086 because my calculator was in the wrong mode. Sorry about that. So if you put your calculator in the right mode and you do the trapezoidal rule with 4 subintervals from 0 to pi, you get 1.89611. And then if you do 8 subintervals, you get 1.974. A little bit better. Sorry about that. So moving forward here, when we are in the right mode, you type it in the calculator using Simpson's rule, and you get a much better approximation than using the trapezoidal rule even. So Simpson's rule is a little bit better. Your homework will be page 316, 1 through 19 odd, 39, 43, and 45. I will give you a chapter 4 review worksheet tomorrow, so you can work on that over the weekend too if you want to. And then we'll have a chapter 4 test on Tuesday, January 15th, and we'll review Monday.